Alright, so we got a chunk of steel here, and this is for the actual toe part of the toe jack, and so I needed kind of a big monolithic block. I didn't want to make this up out of pieces and weld it together. So I went to the scrap yard and poked around, and I found this guy here, which is pretty good. It's sized pretty well to make this the toe component. But it's actually, this block is kind of interesting. You never know what you're going to find at the scrap yard. So let's take a look at it. For starters, I chose this one because it was ID'd, at least lightly. And what this is here, this is the secret code here, 15.5H1050. Okay, so what this is 15.5 pH precipitation hardening stainless steel. Okay, and it has a heat treat of an H1050, which is actually a fairly common heat treat to machine in the heat treated condition. So which is what we're going to do. Okay, so this will come out, you know, we'll machine this and there won't be any further heat treating, and it's well over 100,000 psi yield strength the way it is right now. And that's a little bit hard, but not too hard. It's about 38 to 40 Rockwell, something like that, in this heat treat condition. Now, what's interesting is this is probably some leftover aerospace part deal here. But what caught my attention initially in the scrap barrel that I was looking in was this feature on the bottom here, and you can probably see it a little bit. It's a dovetail, and what this is this is a heavy-duty holding feature for doing kind of major machining on a big heavy chunk like this. So you know, they have 100,000ths or an 1/8 inch of grab stock that's a dovetail, so the jaws are dovetailed to fit in here. Now I'm not sure what these scallops are here, if that's part of their scheme, their dovetailing scheme. Somehow, I kind of don't think so, but maybe it is. I don't know. But you can certainly see the dovetail. Now I've done this myself many times to really hold a part with very minimal grip, but hold it very securely. You know, as long as you close the jaws of the vise, you can almost forget to tighten them up, and it's not going anywhere. So anyway, that's what that's about, and we're going to make this toe. In fact, I've kind of marked it on the other side here. You guys get an idea here. So this is the keeper part here. So all this material has to go away, which is a fair amount. And I'm going to give it a go and see if I can bandsaw that out of there, but that's pretty thick, and this stuff's pretty hard. So my guess is it'll be pretty slow going. And my Johnson saw is kind of out of commission anyway, and so we may end up just milling all that out of there, which will make a pile of chips. This is 14 pounds right here, so it's fairly significant. So that was $50 at the scrapyard. So all right, so here's the setup here. This is a Lennox Diemaster blade here, and this is a 4-tooth per inch blade, and we're running about, I don't know, 60 feet per minute, 70 feet per minute, something like that. And this is our 15.5 pH H1050 block. You can see I'm already, this is actually going to work really good. It's going to take a little while, and no, I'm not going to film the whole thing because it's pretty boring stuff, but it's slicing through this pretty nice. So I'm going to lop out that chunk, and I'll end up with a nice piece of usable material as well, kind of left over, you know, that doesn't end up as chips. And this is going to be a lot faster than milling all that garbage out of there. So let's do a little cutting so you guys can see that, and then I'll get to it, and we'll come back on the mill. So I'm using my belly board here just to put a little more feed pressure on it. patience is the name of the game here. You can't get greedy, you just have to let it do its thing. So you can see the nice chips coming off of that. That's 4 inches right there. Lennox rocks. Look at that. That saved a bunch of work. Look at that. That's about 6 pounds right there. That would have been on the floor over near the mill. So, blade kicks ass. All right, so we got our block of 15.5 pH stainless here that we sawed out, and so there's still a lot of milling to do on this, and you can see all these edges are basically saw cut. These look like they were milled, but there's nothing trustworthy on this. So what we got to do is we got to establish some working datums on this thing so that we can flip it around and put it in the vise, and it'll be relatively square. So so I really want to do these large surfaces first, but I think I'm going to do some light squaring on the skinny faces, because what I really want to do is put it in this way, but I notice that it's kind of ski-whacked. So I think we're going to start like this, and I'll dust this off, and then I'll flip this over, and I'll get this parallel, and then we'll get this perpendicular to that. So this is kind of like making an angle plate. There's a lot of surfaces that are perpendicular to one another, so you can get messed up pretty quick. Now we're going to use, Uncle Chuck over at Outside Screwball, he's been talking about his screwy balls, and that's actually a pretty common technique in machining, is to use a ball with a flat on it to help centralize or make sure that surfaces are pressed up flat against the vise job. Now what we're going to do here is, since we can't trust this surface here and this surface is down, and in fact I tried it with the ball already, and the piece rocks up when I clamp it against the back jaw. So what I'm going to do is I'm going to raise it up with a little rod in the back. This is this aluminum filler rod, and that's going to go in the back corner. So what that does is it makes that bottom edge parallel, okay, regardless of what the entire surface does, but it allows it to pivot up and be against this back jaw when we use the screwy ball there. Okay, we'll just call them screwy balls. We'll give Chuck that. So you don't want to whack this down. You want to just make sure you're sitting down on stuff, and then snug it down. And then I always look behind there to make sure that it's bearing evenly against there. Okay, and then we're gonna touch that down pretty good. Gronk. And then we're going to take some light cuts across this until we get a decent surface. You know, there's plenty of extra material here. Oops, let's go off of there. Yeah. So we'll get that skimmed, and we'll get some of these big surfaces, perpendicular and flat, and then we can use those to roll around on. So let's start cutting on that one there. Okay, we're going to use our 2-inch Glacern face mill, and running about 500 RPM. Let's see here. I think I'm just gonna go across there with a kind of a light cut, maybe 10,000ths, because I don't know how crooked that is. That feels pretty good. It does look like it's deepening at this end here. Okay, so just a quick comment there. You notice that at the end I kind of hand fed it. So the piece was like, you know, that surface was like this, so that the cut was deepening as it went to that end. This isn't the most bomber setup that you can possibly have here. So what I wanted to do is switch to hand feed, and then I get a little bit of feedback through the handle, so I can tell how hard this cutter is pushing on that piece. And turns out I wasn't pushing that hard at all, and I was just being a baby, so it was fine. But you know, you get a little bit of feedback through the handles. That's the point I'm trying to make. And sometimes when something feels a little or looks a little funny, you can get a sense of feel through the handles. So now we actually there's a little bit of saw cut left. I think I'm going to go ahead and clean that off. And then we have a decent datum that's parallel, at least, with this back corner, and now we can turn it over and we can work that large face. So I'm going to take another cut and then we'll flip it over. Alright, so we got the setup flipped over here, and we got our screwy ball in there, and we're pressed up against that, and then we're sitting down on our freshly milled edge. That edge is going to get recut, so I'm not too spazzing out about it. I want to get these large surfaces cleaned up, because if there's any dips or waves in them, it could be a lot of material to take off, so I want to make sure I get those first and then work on the smaller surfaces. Now, this is, yeah, I don't know, kind of a little bit of a funky setup, because we got a big overhang here. Now this is pretty thick. It's possible that we might get a little vibration with this, so that's a possibility here. Once I get this surface and this surface parallel, I can put some taller jaws in here. I suppose I could put some in now, but let's just try it and see how it works. And if it complains, and I don't need to take big ripping cuts here either, so make sure I'm tight. Yes, I'm tight. Let's see how it behaves here. Too bad. Nothing too frightening, but you know, when I come over on this side, then that's when it will do the devil over there. So we'll see. I'm just going to do a min clean on this, and then work my way around and get everything squared up and then go back for size. That's okay, but that's over the thick part there too, so. Got a little hum coming off the back, and there's a little fuzz in the finish there, although you can feel it. All right, let's see if we can get a doesn't like coming off of that edge. Interesting. Okay. Well, let me see if I can get that. I'll get one more cut on it there, and then we'll change the jaws or something here. We'll change our setup. Interesting. Okay, so on a whim, I tried something before I switched jaws. Actually, I didn't have any jaws that are steel that are tall enough here, so all I had was aluminum ones, and they're not ground. So I tried this. I put this is called a coin. Let me take it out, and you guys can see it. A couple little pieces of paper under there, and basically it's a little kind of an adjustable parallel. Okay, these were used by typesetters to lock the letters into these letter boxes, I guess, and you know, for printing. But they're kind of a nice adjustable parallel that you see it's got like a gear tooth on it, and then it's got a little tool that you can whale on them. And now I couldn't use the tool in here, but I could use a screwdriver to open it up. So all I did was put some cardstock under there and then open this up until it was touching there and put a little bit of force on it, and you can see the finish is pretty nice now. It quieted it down, and that chatter as it was coming off, which was kind of interesting. So it was on the heel of the cut as it was coming off. So but there's a little line there, but you can't feel anything, so that means it's not much. All right, so I think we got a method here that keeps it quiet at least. Gives us a decent finish. So now we got one side pretty nice right now, and now I want to get this side that's touching the vise job nice and flat and perpendicular to this one, and then we'll be in pretty good shape at that point. so just for fun, we're going to see how square we got that thing. So let me get the my little comparator zeroed up here. I'm just calibrating it on this angle plate. All right, that looks pretty good. All right, let's get that out of the way. Let's bring our little victim over here. Let's see what we got. What is that? Let's see, bring it into the frame a little better there. So, what is that? 1.5 thou. Let's check it over here. Over that distance, about 2. Go back here, let's see if it reads the same. Yeah, 1.5. I gotta get up over it here. Yeah, almost 2 there. Let's flip it over. And, oops, my stylus is above surface there. No reading. So these legs are different lengths. I set it on the I set the height on this this upper leg here. Do it again. Bring it over. And 1.5 there. And about 2 there. Okay, so that's not bad. That's not bad for just throwing it up in the vise. So that's perpendicularity of these two surfaces there on this. So I think it's close enough for a toe jack. All right, so now we're just squaring this up so that we can kind of get these end surfaces square. So we've got the big main surfaces pretty perpendicular to one another, and then these are perpendicular to those sides, okay? These small faces here. So now we have to establish these end faces here perpendicular. So actually we're doing it in 2 directions at one time here. So we're using the screwball to push it up flat against the back jaw, okay? And then, so initially I just use a little machinist square here to get it close, right? Now I'm going to indicate along that edge to make sure I'm square this way. So that gives us square in this direction and then square in this direction, okay? So loosen that, run down. So it's about 2 thousandths. Let me give it a little love tap there. That's looking pretty good. Yeah, re-zero there. So, yeah, okay, that's going to be close enough. Let me tighten this up. Get it nice and snug. Let's just double check, make sure nothing moved. Yeah, okay, looks good. What do I want to say? I don't know, nothing. I'm using a spacer in here. That's the only thing that's a little bit strange here, just to push that ball out. And actually, you know what? I'm going to bring the camera around to the side so you can see that there's a little space under this other side, so you can see that it's tilting it backwards up against this nice flat jaw here. So we'll get a close-up of that. Okay, so you can see that under there. And in fact, I can get this this about 16 thousandths thick here. And we're sitting down over at this end, and we're nice and tight against that. But that the screwball is pushing it back up, or it's allowing it to tilt back into this jaw, which is what we care about. So now the only thing you got to be careful of is if the tilt's going the other way. So for example, the tilt's going this way in this case, right? So if the tilt was going this way, the screwball would be wanting to push that corner down. So that's why you got to be a little bit careful when you do this, and in that case we would raise this up in this corner so that it could tilt down in that axis to keep this edge flat against there. That's the primary goal there. So Anyway, so let's dust the top of that off, and then we can flip it around, and we just have to make the other side parallel. So. Alright, that was a fair amount of milling there. You can see the pile of wreckage here. It's a lot of material. I probably could have bandsawed it a little closer, but okay, 815, that's my number. Let's check this one here. Should be like 630, something like that. Yep, 630. Okay, good. So I think you can see that there's a little bit of the pattern from the roughing end mill, and I actually want that because that's the toe part. So this is the part that will actually touch the thing that's getting lifted. So I want a little bit of, I don't know, tread or whatever on there. James Kilroy said that the Stalker has some lines in it along there, and just to give it a little extra grippage. So, so this is the thickness, that's the thickness. I got to do the length, and then, excuse me, then there's some fancy pants milling here where we do a little operation that looks like this, right? Can you guys see that? Yeah, you can see that. So we're going to take out all this beeswax here, and that's the actual toe there. And then, of course, the mounting, there's some mounting holes that go in there too. So, okay, so I'm going to deburr this and take a little break and clean up this wreckage, and we'll come right back. Alright, I think we're ready for a little layout here. So we're going to scribe some lines that define the toe part of this. So this thing gets used in this attitude here, up and down here, and this is the actual toe part. So we're going to start, we'll lay out the sides. We're just going to scribe this stuff with the height gauge. Nothing real fussy about any of it. So this gives me symmetry here. Okay, so that's the toe. So hopefully you can see the scribe line. I don't know if you can see those scribe lines. Okay, and now let's see, the next we have to define where this angle starts and comes down to there. So let's do the lower part there. 190. Just want to give a little. See, like, can you guys see that? Try to get in there so you can see that. Kind of hard to get in that corner. I just need a little line to define where that angle emanates from. This would actually be a good one for the other type of. I got one in here handy here. I do actually. So this type here, where it's just a single scribe. And it would, you know what? Let's go ahead and use that. Why not, right? let's talk about it. Doall. Okay. You gotta watch it, you know, poke yourself in the fingers with these things here. Getting everything spun around the way you need it. So this, with this angled, the angled scribe here, you can get right down into the basement there. Let's do that. Let's come up more. Something like that. This thing needs a little bit of liquid love. So, and then what we can do is just use this to calibrate it. Let's see if I can do this so you guys can see what the hell is going on here. Alright, so I actually got it pretty close. A little more. I'm hitting up there. Okay, that's good. If I can get up in there now. That'll work. Felt like it moved a little bit. This is where you need one of those little rule holders like Adam has. You can hold the ruler and then you can use it to set your gauge. Because I'm trying to hold on to like 3 things at once here. Make sure that's tight, make sure that's tight, make sure that's tight. Double check. Moving on me there. Yeah, it's right up in there. Oh yeah, that worked. Okay. All right. So let's see. What's my next number here? Let me zoom in a little bit. All right. So one nice thing about these particular height gauges here is you can count down with them too. So what we're going to do is we're going to zero out on the top here, okay, and then and we can take a measurement down from there. All right. So I'm looking for 1H 188. Oop, wrong way. So it's 188. So that's really nice to be able to come down. So that's the end point of one of our angles there. Swing around this side here. Hopefully you guys can see that. Okay, so if I connect that intersection with that intersection there, that's our angle. I don't even really need to know what that angle is, just where that intersection is what I care about in this case. But we'll probably go ahead and scribe a line just for ha-has, so that we have something there. So okay, all right. So we'll probably bandsaw most of that out of there, and then come back and clean it up on the mill. And let's go do that.